this. And all right, so thanks everyone for joining this TrustedSec webinar, seeing the entire software security picture. My name is Nathan Knoll. I'm a marketing manager at TrustedSec, and really excited to have the team present this today. You're going to see some of the challenges that our clients and partners face with software security, how we overcome them. You'll get a couple entertaining examples of the web then and what the web is now, and how that relates to software security for your organization. So before we get started here, wanted to talk a little bit about TrustedSec if you're not aware of us. We are a full service information consulting firm. We work with all kinds of companies, from small mom and pop shops to the largest companies in the world. Here is some of the ways that we help companies with all of our different services. One way that helps me to kind of look at this is all the different ways that we help, whether it's building an organization's security program, coming in to test their security program, or fixing it. And then if there's any kind of incident response needed, a breach, TrustedSec is able to come in there and help out. And you're going to get to see that example of the type of team members that you would work with our team here. And before I kick it off to Scott, Geoff, and Rob, just a couple quick housekeeping items. This webinar is going to be recorded, and then it will be available on our YouTube page. So if you go to our website or our YouTube page, you'll find it there. We'll also be sending out an email once the replay is available, and you'll have the direct link to view it there. Lastly, any questions, definitely highly encouraged. You can ask them throughout. Use the Q&A function if you can, and then we'll be happy to answer them either during the presentation or directly following it. We have time allotted for that as well. So I think with that, I'm all set, and I'm going to kick it off to Geoff here. And thank you again, everyone, for watching.
Well, hello, everyone. A little bit about myself. I'm a principal security consultant here at TrustedSec on our software security team. I've been lately a penetration tester and a software reviewer. Some other things I've done in the past is speaking at DEF CON and helping to organize the Capture the Flag event at DerbyCon. Like all the members on our software security team, at least the senior members anyway, I've done some things in a past life. I've done information security at the network level. I've been a network administrator. I have done work as a web developer, especially in the line of business area, working internally within an organization. And I worked as a data warehouse architect for a while. So we all try to bring kind of a broad range of experience to the table when we look at apps and do testing. Rob?
So my name is Rob Simon. I am also a principal security consultant here at TrustedSec on the web app team, specialize in web, mobile applications. I've also done some hardware and IoT type stuff. I've presented in the past at DEF CON and DerbyCon, also with Geoff and Scott. Throughout some of the years have been on the DerbyCon CTF in terms of creating some of the challenges, contributing some of the challenges to that. In my past life, I actually came up as a software engineer, so I did spend some time doing development before moving over into security and through security architecture. So I feel like that kind of gives me some good experience there and some understanding when it comes to doing assessments, understanding the developer side and the kind of stuff that you have to go through when we make those security recommendations and things to fix. Understanding the effort that's going to go into some of those things as well. Also, got video game hacking on there. That's definitely a hobby of mine that I used to enjoy doing a lot, and still get to play in as well a little bit now. So if anyone else out there is interested in that, we are in Discord, so you can always hit me up there if you want to talk about some of that stuff. Scott?
Hello, everyone. My name is Scott White. I'm the practice lead for the software security team at TrustedSec. Like everyone else, I have a varying background. I'm a former web developer, system administrator, and also help desk. Seeing that I'm a former web developer, that definitely helps when it comes to the tax side of things for websites and web applications. Knowing that how they're built from the inside out kind of gives me a little edge, perhaps on other testers. I've got a bachelor's degree in computer science and a master's in network security, so I did that from the academic side before I kind of did security professionally. I've also been the technical editor for a couple books that are pictured in the bottom right. David Kennedy, TrustedSec's founder, is also the author on the Metasploit book down there. I have run the CTF for DerbyCon for every year that it's been there. Geoff has been instrumental, and Rob as well, in making that a success throughout the years. As well as the others, I have spoken in a variety of places, and I've also been called on by the FBI and Secret Service for to be a subject matter expert for various things, usually relating to web applications or databases. I've been doing this professionally for over 12 years and have some very interesting clients, everything from breaking into cruise ship, casinos, 911 networks, all sorts of fun different things. Outside of kind of client work, bug bounties and zero-day hunting in my free time are some of the things I like to do. And I don't really do much Twitter or social media in the information security world. So enough about us. Let's talk about what we're going to cover today. We're going to take a look at the web then versus now. We're going to take a look at OWASP, the Open Web Application Security Project, and how it's changed over the years. Take a quick look at cloud stuff today, some of the trends we're seeing, some of our things that around application planning, whether you're going to create a new application yourself or purchase one, some things to think about when you're doing that. Also cover some testing terminology. There seems to be some ambiguity and perhaps confusion in the field. So we'll kind of give an overview of what we call things and what those involve. And then also we'll take a look at some tools and technologies and things to consider from that front. So back in the day, whatever that might be, 20 years ago or so, we had some single technologies. So you'll have a web page written in one language and it's hosted on some hardware platform, and that's about it. Today's applications are much more complex. Back then we had simple request responses, static pages. You had your dial-up internet connection, and you'd click on something and wait to get the response, and things were quite slow. There was a lot of focus on just client-server architecture. You had a web browser and you had a web server. That was it. There wasn't, we didn't really have too many things in the notions of web farms or anything like that. It was very send your request, get your response, and that's it. There wasn't much more to it. It wasn't a whole lot of rich content, no dynamic content, things updating. It was kind of the, here's your screen, here's your static display, click refresh to get a new version of it. Weren't a whole lot of videos or user-generated content. It was very static. We had things like Bonzi Buddy, as we see there, a lot of animations. You have to get the dancing baby up there. A lot of the MySpace era or before, the sparkling TrustedSec there, the marquees, things like that. Flash, ActiveX would be kind of your interactive type things. Also, any server-side includes or CGI. A lot of that was around then that we don't really see too much anymore. There was a big scene with the wares and keygens and the pirated software and Napster and all that good stuff, where you'd have your illegal content that folks would download or focus on. So that's still out there today, but I wouldn't say as prevalent. So continuing on to what else there were, online guest books. So this kind of graphic on the right here kind of illustrates, if you've seen a web page from the 90s, perhaps even 2000s, a lot of this will probably give you flashbacks. The guest counter, the online guest books, the marquee or blink tags, lots of frames. You might have your menu with your navigation for your site in a different frame. Very basic, very kind of original Nintendo 8-bit, 16-bit looking type things. You might have an HTML form to send email that might call a script. not a whole lot of database interaction, perhaps, with most of these web pages. A lot of them are static. Typically, you'd see a single DMZ, if any at all. So back in those days, we would hack something. Half the time would be on the internal network. We wouldn't even really have a DMZ. So things have definitely changed with VLANs and segmenting today, unlike perhaps 20 years ago. Now, everyone's hosting in the cloud or with redundancy and all this other stuff. Back then, usually you had hardware that was hosted locally, or else you'd hit up some other sort of site. GeoCities might come to mind, Tripod, AOL. These are pre-remote desktop days. I remember when I was a system administrator around the year 2000, we finally bought a device for KVM over IP so we could actually get to the BIOS level on our servers over the VPN, which was fancy at the time. If we had an employee that would call the help desk, say, hey, I have an issue. There wasn't, hey, let me shadow your desktop, let me remote desktop in. I had to actually go out and walk the factory floor and memorize and know where all the employees were that had a computer at the time and actually go visit them directly. We actually had bicycles that we rode around the factory so that we could, cover that huge factory much more quickly. Also back in the day, I think dial-up, ISDN, back people were like, ooh, our company has a T1. Well, that's not very fast by today's standards, by all means. So things back then were quite different, and today they're very different. Today we have kind of the notion of Web 2.0 versus 1.0. We've got dynamic content, rich content, single-page applications. Things seem to refresh on the fly. As you do a search, the results dynamically update. It's a nice user experience. Now we have the Internet of Things. We've got our toaster, our fridge, our whatever connected to the internet. I've got security cameras, my garage doors, different things like that allow me to stay in touch and understand what's going on at my home while I'm not home. Organizations have APIs everywhere, so whether they're for their own consumption or public consumption, so you can build an app around whatever that organization's services are. There are APIs that weren't really around in the past. 20 years ago, it was probably a lot of scripting and things like that, not necessarily the notion of APIs. Now we've got cloud everything. So there's a lot of kind of management and overhead and responsibility that's being done by someone else. The beauty of the cloud also is you only pay for what you use for the most part. So if we want to fire up a new VM or whatever it might be, that virtualization technology and stuff like that, you can really save on cost there and only use what you need. The redundancy and the availability is like no other compared to 20 years ago. Today's applications are very different. Some of the ones that we review from an architectural standpoint might have 20 or 30 different technologies in place and its own network diagram. The entire network diagram for an organization I worked for with a couple thousand employees 20 years ago, that same network diagram, the size of that, the number of devices in play, would be similar to a single application in today's kind of standards. So those technology stacks are much more complex, a lot of pieces in there, a lot of things in the mix. Microservices and frameworks are huge. There's a lot of things, you don't have to reinvent the wheel. There's a lot of things that are available, whether it's free open source software or if you purchase it. There's a lot of things available. Also microservices, things are built with a tiny purpose. Purpose-built things, it's easier to take a look at that code and manage it. So that's nice that you can focus on just a small piece of what's happening and manage it from that front. Also, everything is a service. So whether that's platform as a service, software as a service, you can pretty much purchase anything you want today. Whether that's infrastructure, servers, outsourced development, whether that's help desk services, pretty much anything as a service could be offered today, or you can procure today. Another shift we've seen now is JavaScript used to be a lot of client side, but now we're actually seeing server side. We see it both sides. Also, JSON Web Tokens, another thing that's we're seeing that's kind of evolved. It wasn't around 20 years ago. Those static websites that we used to see were usually built by hand. Today, we have a lot of WYSIWYG point-and-click tools. A lot of websites are running off of a content management system, and we have relational databases on the back end of a lot of those that allow things to be much, much more powerful, have much more kind of business logic, workflows, and intelligence behind it. Also, we have, today we have DRM and licensing issues. They were licensing back then. Rob on the webcast or on the webinar here, as well as myself, had an interest in software security back in the day, and the licensing schemes that are in place today are much different from those 20 years ago, and the way that organizations go about, I'll say, attempting to protect their intellectual property is much more involved and more complex today than it was before. So what else do we have today? We have that rich user experience. We have video. We have, if anyone uses Facebook, or it might be other technologies or other social media as well, they've got 3D kind of photos where you can pan your phone around and your mobile device and take a look at those. Those are cool. A lot of that stuff that we didn't have before. Content tagging, single sign-on, sign in with Facebook, sign in with Google, sign in with Apple. Use your one sign-on for everything, and part of those APIs and those things that are allowed, that are exposed, allow you to take advantage of those and let them do the authentication piece for you and validate that they might be a valid user before you, have that done on your application. Social media, obviously huge now. That wasn't so much back then. We've kind of not really a whole lot of the BBS IRC anymore. Now we've got the mainstream social media that's obviously in play. Just with the top right, the graphic there on the slide shows a bunch of different sites and services that folks might use, and there's so many of them I haven't even heard of half of them when you start to look at the names of some of them. Oh, we've got wearable technology, smartwatches, pedometers, everything's connected. Your phone, your laptop, and your watch, and you can make phone calls from your watch now and receive text messages and things like that. Just simply weren't around before. Going along with kind of the AJAX thing, with the web sockets, allowing kind of the dynamic content, things behind the scenes that we didn't have before, really brings that user experience to life. The user content has changed. We really have product reviews and comments and things like that. So when you go to buy something, perhaps it's on Amazon or whatnot, you can go read the reviews of the products. That really wasn't a thing. The online shopping wasn't as big as, or it's much larger today. Look at the richest man in the world is now Geoff from Amazon, when it used to be Bill Gates. So the online shopping is huge. And then also today we're seeing multi-tiered DMZs, complex architectures. It was just a web server before. Now we might have a load balancer, a web application firewall, a server farm, an application server, web server front end. We might have message queuing in the mix, all sorts of different things like that. And then I'll call attention to the bottom right. We have Doom, some folks that have played that game back in the day. This is actually a screenshot I made the other day. This is Doom in your web browser. So the technologies have come a long way, and a lot of things what we're allowed to do, what we can do there. It just shows that that's impressive. We can actually play Doom in the browser when before it required a computer lots of hardware per se back in the day. So switching gears from then and now, let's take a look at OWASP. It's the Open Web Application Security Project. Hopefully you've heard of it before. It's a great organization. It's a nonprofit organization, and its goal is to arm developers with necessary tools and resources to protect applications from attack. So the key here is OWASP is free. So they've got all sorts of different resources, whether it be tools that you can use for testing, checklists to make sure you're doing things correctly, or they have an OWASP testing guide if you want to know how to test for the latest vulnerability, whatever it might be. The OWASP testing guide is a couple hundred pages long. It will actually teach you how to hack, how to test for a particular vulnerability on your application. One other thing to note here, if you're into kind of instead of the online thing, most major cities across the US and around the world have an OWASP chapter that hold regular meetings, and they have presenters and different activities that they do. So if you're interested in that, perhaps check out their chapter list and see if there's a chapter that's near you. OWASP also publishes what they call their top 10 list. These are the top 10 things that they kind of see from applications in the wild, the most relevant issues, security issues that the applications are facing, how they're getting hacked, and mistakes that developers are making. The first one started way back in 2003, and then they had versions of 2004, 7, and 10. Also 13, and the current version is 2017. And why I like this illustration is we can see how things have changed. Back in 2003, we probably had just a web server and a firewall, just a standard firewall up, and buffer overflows are listed as a web application. Today, we have frameworks that do a lot of that for us. So any sort of memory allocation, garbage collection, all that stuff, a lot of the languages are already taken care of for you. So a lot of that kind of goes out the window. Back when I did my university education, was kind of the dawn of when all this began from security as a professional standpoint. And we learned assembly language and C and C++. And one of the things I've noticed when we're putting on training courses for clients is that some of these developers might learn how to code but not truly understand core concepts such as memory management, because a lot of these object-oriented languages take care of things for you. So it's important to understand the technologies you're using, how they actually work. When people ask me, how do you become a professional hacker? I tell them, well, you need to do everything else first. You need to do help desk. You need to be a web developer. You have to understand those technologies before you can defend against them. How do you know to lock your door on your house or lock your windows? Well, it's because we know that someone can climb in or break into our house that way. Well, I need to know how the inner workings of my application are before I can defend against those. So this slide's interesting. That shows some of the shifts. We don't really see buffer overflows anymore. Those, we don't really see a buffer overflow associated with a web application in these days. So moving on to 2010 versus 2013, we've seen kind of injection be the number one. So whether that's command injection, SQL injection, those are some of the biggest ways that we've been breaking into applications. And we've seen some of these things kind of merge into different pieces. So the ones that are brown and red, we've seen some merging, some changing of number of the ordering there, and the ones that are most popular as far as what's happening in the world. So we can see here the top 5 have kind of stayed the same. And moving on to 2017, we can see that there have been a few things merged and a few things that have shifted. And this is our current kind of latest version that's been published. And a lot of these I would agree with on how we break into our applications, a lot of injection flaws, anything related to authentication. We still have issues with weak passwords, user enumeration on password resets, anything with say LinkedIn breach from 2012. We're still reusing credentials from them to break into web applications. Those applications aren't forcing a password reset. Things like that, we're continually breaking in with. So with the top 10 2017, here's the final list. We have some other pieces that I would say aren't even really thought of 20 years ago. For example, A4, XML, external entities. Even though XML, has been around a while, that's the type of kind of vulnerability where we've taken things to the next level. Today's vulnerabilities, back in the day, it was, hey, run this script, execute the buffer overflow, get a shell. With web applications and application security today, whether it's a mobile app, desktop app, the client, thin client, whatever it might be, a lot of the hacks we're doing today are multi-step hacks where we're taking advantage of multiple vulnerabilities. So that verbose error handling might have given us a file system path. That unrestricted file upload might have given us a way to upload a file. And the way we access that uploaded file, we found out through that verbose error message. And we use multiple things together to achieve that end result, that end kind of hack, whatever it might be. So that's kind of an overview of OWASP and how the changes have been there. Next up, we'll have Rob talk a little bit about the cloud.
So yeah, Scott has mentioned, in the past with applications, we've seen it used to be, you just have a server with the application, maybe it connects to a database, it's all hosted on premise. So applications have came a long way. And, when you think of application security, you have to think of just more than the application itself. While that's an important part of application security, ensuring the application has been coded in a secure way, part of application security is also kind of planning and design architecture. How are you going to deploy that application? And that the way that you deploy your applications has changed a lot. Since web applications have kind of started up. So, like I said, in the past, you might have hosted things on premise, but now we've got cloud hosting, and that comes with its own unique security considerations as well as, potential for GRC or PCI type concerns, and cloud specific features. So for instance, with cloud hosting now, you might have features available to you that you didn't have just say hosting on premise. And things might depend on which cloud hosting provider you're going to go with. So Amazon has specific features to them. They've got their relational database service versus say just spinning up your own box with a SQL server on it. That's an option that you can look into, and that might come with its own security considerations. A lot of them have keys to manage things, and you've got your key management to deal with, and that might be done differently, from cloud to cloud. Active Directory is not just on-premise in your own environment anymore. But you can use Azure AD now. So now you've got your Active Directory, could potentially be in the cloud. And hosting in the cloud, that doesn't necessarily mean the application is just, everything's in the cloud, but you can have your environments kind of interconnected there. So you can still have stuff that's in your environment and stuff that's in the cloud. And now you have connections between the two environments. So that's another thing that you have to think of. So you may not necessarily be, completely segregating your infrastructure if you've got, some pieces, databases or Active Directory hosted back, on premise, and you're making connections back from the cloud environment. So those are all pieces now that have to be considered. And there's some areas that you can kind of start with in terms of securing the cloud environments. There are CISecurity.org has the CIS benchmarks, and they have some for the major cloud providers out there for AWS, Google Cloud Computing, and Microsoft Azure. And this is just an example of some of those benchmarks, and we won't go through, the benchmarks in detail, but, just for instance, this one's showing for Google Cloud Platform Key Management. And the benchmarks, if you're familiar with some of the other CIS benchmarks, this is going to be very similar. They have their, scored items and their non-scored items, which is kind of, going a little bit of the extra mile in terms of securing your environment. So you can go through the list, look at each of the items, and they give you very good description as to what the issue is, the rationale behind that, and how to audit for that, and then how to address that, going down to either through the console of those cloud platforms, how to navigate to those items and address them, whether that be key rotation or anything like that. And then also usually the command line parameters that you can use in there as well. So these are a big help if you're moving to a cloud platform or you're evaluating it. I would highly recommend checking out the CIS benchmarks for those cloud platforms and take a look through there just to see, some of those security considerations that you should be thinking about. So some trends that we've seen, we started with web applications. Now we have mobile applications as well. It used to be you could only do online banking, but now, with mobile devices, everybody's got a mobile phone, or almost everybody has a mobile phone, a smartphone. You can run applications on there. We're always connected, with a internet connection on the phone. So now you can do everything on the go. And we've seen like a rise of, lots of companies putting out mobile applications. And along with that, APIs for public consumption now. APIs used to be used, maybe just internally, not necessarily exposed out to the internet for others to use or consume. But now, not only just to be consumed by mobile applications, but we also see APIs that are out there for public consumption. And as we introduce new technologies, not mobile, a lot of times we sometimes see, as new technology comes into play, sometimes we start to see some of those same things, from the early web, issues crop up again. As people are getting into kind of new areas of development, new areas of applications, and then making some of the same mistakes in the past, with not validating input or hard coding secrets and credentials and things like that. We also have single sign-on now, where we're not just having usernames and passwords stored in a database, with a SQL command to go check that, but now we're integrating sign-on with Facebook or Google. Or other single sign-on providers, single sign-on through Active Directory, so you can sign into one site, sign in once and be signed on multiple sites. So those are new things that you have to take into consideration now, some things that we're seeing. And then software development methodologies as well. It used to be developers would not really integrate security into the lifecycle, and we're starting to see more of a push to get security integrated into the software development lifecycle. Which is really good. And the way that software development happens has been evolving and changing, going to agile methodologies and sprints and moving fast, trying to get short 1 or 2 week iterations to get new features, planned, released, or developed and then released, all within these short timeframes, which can make a challenge for integrating security. So it's really important to kind of keep that in mind, and security needs to be flexible and try to move with that to make sure we're integrating, because it's important to try to plan for that stuff, early, as opposed to in the early days, doing security at the end. Because when you're doing security at the end of development, and if you're not planning for it, within the design phase, as features are being developed, there could be major design decisions that were made without accounting for security, that if you find something significant at this point, it can be hard to go back now and fix those things or address the security concerns without major rewrites. So if anything, it really just helps to make sure you're planning for security and trying to integrate that into your development lifecycle as early as possible and as often as possible. So another thing that we've seen is hacker motivations. They've changed and evolved over time. So, back then, some of the stuff that we've seen, and, it doesn't necessarily mean we don't see these anymore, but it looks like, we see a shift in this kind of stuff. There used to be a lot more website defacement, in the name of hacktivism, piracy scripts and flutters, using, public open shares, mostly to host, illegal files or whereas. So we've seen a lot of that where, things were just hacked, for the fun of it, or to, to deface things, get your name out there. A lot of piracy, doing things just to, again, street cred, so to get your name out there. But, now we see more of a shift into that organized crime with, the motivation of getting intellectual property or getting money or extorting businesses, for Bitcoin. We see that a lot now. Now with cryptocurrency, it's easier to try to get some kind of an anonymous payment out of somebody. So we see a lot of that with ransomware has moved to that. And ransomware even, just ransomware itself has even evolved where they get more sophisticated. It used to be they would maybe use hard-coded or static keys. And then, with a little bit of reverse engineering, people could find out that you could decrypt those files but now they're moving towards PKI, public-private keys, and ensuring that without going through them, you're not going to be able to decrypt those files.
Rob's talked a lot about how the software development lifecycle has changed, and certainly it has evolved a lot over the last 20 years. One of the things that we look at, especially as organizations, it used to be that large organizations were very functionally organized, and you had one team within the software development group working on a particular project-oriented application, and so you had a lot of tribal knowledge built up around that. As that has evolved, we've seen a shift much more towards a more pure project-oriented type of development groups within organizations, where one team will be responsible for a specific application. And so there's still a huge tribal knowledge for that piece. So if you look in the bottom left corner of this one, you see how the project was documented. In those earlier days, those functional groups, there was a lot of waterfall type work. I might be responsible for this system. The next systems group, took over for the next piece of it. And that has, now that we are looking at much more full stack developers working on an entire project, or a team that represents a full stack for, from consumer enters information all the way to, back-end system order fulfillment. There has been a lot of challenges around communication, business analyst elements of it. And that plays into the software development lifecycle, especially in terms of how these applications grow during their maintenance phase. To speak to the maintenance phase a little bit, that's probably one of the pieces of the software development lifecycle that has changed the most. While Rob mentioned we want security involved, certainly from start to finish, beginning in the design phase, it's actually the maintenance phase. A lot of these things now occur. Certainly, we do tend to add features and stuff to applications during their lifespan. One of the challenges there is original security assumptions sometimes get undermined. We didn't think anybody was able to enter certain type of data, and now suddenly we've made that a feature where end users can customize some of that stuff. So previous parts of the system that assumed certain data out of the database was perfectly safe to use, to display without doing things like neutralizing them, suddenly are now not. And this is where things like architecture reviews can come in. A lot of these occur in the design phase. Sometimes architecture reviews are done later, even in the maintenance phase, prior to a feature addition, prior to integration with another system. Things of that nature are a good opportunity to look at doing some of those types of services. Basically, an architecture review is a TrustedSec engineer or a security consultant will sit there and kind of look at the entire application end to end, primarily from a data flow perspective, just to see how information is handled by each system component and what the security controls are around those things, and evaluate if those security controls are effective as far as meeting the security objectives. Developers nowadays do spend more time in most organizations on secure coding education and awareness. Certainly, when I started, writing software, it was all about the functional aspects of getting the job done. How do I get that text on the screen? How do I generate that HTML page and get it sent down to the end user? Security was, something that you were left on your own to think about and deal with. There is formalized security education now. You can certainly get things like training courses from TrustedSec and other providers to help keep your developers up to speed, keep them aware of these newer types of threats that exist. OWASP has historically been a strong source of that information as well. If you're looking for some free sources to build your own curriculum from. In terms of assessments, there's many types of assessments we can do. We'll get to that in the upcoming slides here. Those are going to be your gray box, your white box, and your hybrid assessments. Black box assessments are still useful, but we do not do as many of those. Application retirement, too, is another issue that probably hasn't gotten a lot of attention historically. One aspect to consider is probably much earlier on in most organizations' maintenance phase. You really should be looking at, well, where do we go next when we decommission this application? What are we going to do with the data? Is it in a format, and is it in a relationship set that entity relation set that's going to make sense for where our organization is heading, or are we going to have an impedance mismatch problem? What happens if we have to retire this application early? Maybe there are some major security issues in it that are revealed. Where do we know what we're going to transition to next? So when probably at the start of that maintenance phase, this is not something that generally happens today, but that is definitely something you want to be thinking about is, well, what's next? What happens when this application ends? Outsourced development, this is another big challenge. Usually you're sending a functional spec to some third party, and they provide a result back, and they're not aware, they don't have the tribal knowledge that traditionally existed with in-house shops. So again, they are making decisions sometimes in a vacuum, and that can present some security challenges as well. Really we're looking at taking a proactive offensive approach to addressing security issues head on, even in the maintenance phase, rather than trying to go, oh, we've got a bug report, let's do something about it now. One way to do that is, something like a bug bounty program, where you're actually soliciting people to find and submit information rather than, hitting those things at the end. So that's been another change in the way the industry works. Looking at software security as a whole, this is another aspect that I think hasn't gotten a lot of talk in the past, but is something that we're more focused on now. Depending on what terminology you want to use, some people in the industry will actually flip this the other way around. There's two things really to think about. There's application security. Are we looking at the security of the specific application that we built? And then there is software security, which starts to look at the broader platform. Okay, I've got a secure application. Am I running it in an environment that's otherwise secure? Do I have that web application firewall that's offering additional protection for it? Is it running on a platform that's patched? What about the third-party items that it leverages? Are those patched and up to date? And finally, what kind of access controls and stuff exist around the other software? I could have the most secure application in the world, but if we're running it on a server with RDP open to the internet and weak passwords, well, somebody's still going to get access to the data because they're going to go right around the secure application and follow that path of least resistance. So there's really an idea of looking at the total package. That brings us into the different types of testing we can do. Black box testing is one of the stronger ways to look at that whole software secure environment. It's a no knowledge approach. In other words, you've hired the application security testing team to go and basically beat up on this application. They usually are not given any kind of credentials. At TrustedSec, our black box test is an uncredentialed test. So they're going to go kind of sniff around the front porch, and see if they can get into the application, see what an attacker who has no access is able to do. This works well sometimes for applications where people are able to create some of their own credentials and stuff like that. But the biggest challenge with this one is that you get limited ability into the application. If you have managed to secure that initial login page, and we're not able to access some of the back-end resources and stuff like that, and internal application resources, they don't get a lot of visibility as far as the test goes. Typically, these are going to be scoped by the number of dynamic pages. In other words, pages that can do things. So again, if we're talking about an uncredentialed website, maybe it's your www page for your organization, where we can do some basic lookups and things about products and stuff like that. Things like cross-site scripting and stuff are still a concern. And this is an area where black box testing can be of strong benefit. It is a more manual rather than automated process. Certainly automated testing tools will be used to get ultimate coverage over everything. However, looking as a human being about how the site's built, how it's structured, making some guesses about how it's designed in the background based on our previous experience as software developers and stuff, are leverage to try to kind of get in deeper into that application and see if we can make it do some things it shouldn't. White box, this is usually a source code analysis. It can be some other things if we're looking at a platform, certain blogging platforms where you may assemble things from previous components that others have built. But generally, this is going to be a source code review. It's an automated and manual process. Certainly, static source code analysis tools will be used, again, to get a lot of coverage. Typically, the approach would be for the tester to go through and look at the most critical components of that application. For a web application, those are going to be things like our controllers and our views that end users are able to interact with a little bit more directly. And on the backside, it's going to be data layer and things like that. How do I map, through the ORM into the database? Can people do things that would cause other records or other fields within a record to be changed, things of that nature. Some of the advantages is you get a full visibility into the application and its inner workings. So certainly as a developer, you can really dig into, you can follow code paths all the way through to their logical conclusion. It's nice because it generates very few false positives. The problems with it are it's incredibly time consuming, especially for a larger application. It can take the reviewer a lot of time just to get a handle about how the application is constructed, how data flows through it, before they can really begin evaluating it for security practices, at least for deeper security practices below high level things like, well, we can see that strings are being escaped so it won't cross-site script and stuff like that. It's definitely your most expensive option, primarily because of the number of hours that are going to be into it before you can get results out. And it also requires the tester to have specific skills and expertise in the programming language and library sets that are being used. Graybox, this is probably our most common and popular type of assessment. What this is primarily an authenticated testing method. Usually what we go for is something like 2 user accounts per role. So if you want to do a Graybox assessment, typically you'll be asked to provide sets of login credentials for every role within the application. And a role is generally a security profile, some sort of collection of permissions that exist. The idea is to get a solid idea of whether both horizontal and vertical authentication and authorization functions within the app work well and effectively. That is, if I'm user A, am I able to access data that belongs to user B when I shouldn't? If I'm user A and I am a regular user, can I get to that admin page that should only be available to user B, who is the administrator to change settings and affect global site-wide things within the application? Again, this is going to be a manual approach. The user is going to log in. They're going to use a dynamic software evaluation tool like Burp Suite, something like that, so they can see the protocol, so they can maybe tamper with some of the functions as they're testing. They're going to do pretty much everything that we would have done in a black box test, but in addition, because they have credentials, we're going to get in and be able to do that additional authentication and authorization type testing. This is probably a good way to get a lot of coverage at a very reasonable cost. Finally, our hybrid white box, gray box assessment. This is basically a blending of the white box and gray box assessment, just as you would imagine. What it generally is for us is a source-assisted gray box. So primarily, the effort will be placed on the dynamic testing gray box side. We'll be doing the authentication, authorization testing, just as we would for a gray box test. When we do find something that appears to be a problem, appears to be access to data we shouldn't be able to, we can go deeper into the source code and begin to understand, why that occurs and possibly provide a little bit of a different and additional assistance as far as the resolution there. Another thing we can do is we can use some of the static analysis tools for the sake of getting an idea of where some of the problems may be in that application and focus the gray box testing efforts there. And finally, still doing some of that manual source code review, again, placing an even stronger focus on those front end and final data end components. And with that information, go and test anything that looks suspicious dynamically, which is usually a little bit faster than trying to do desk checking of the code and fully understand that code path sometimes. And that helps us get a quick answer. Is this going to be exploitable or not? Is this something that needs to be fixed and reported on or not? It's a lot less expensive than a white box, just because, again, the dynamic access and runtime environment give us the ability to kind of cut down the amount of source code we actually need to specifically look at. So this is a good way to get good coverage for your dollar, a little bit better coverage than gray box, but maybe not quite the investment a full white box would.
So Geoff just went through white box, gray box, black box, and hybrid, and that mostly kind of covers, how we define the web services. We also have some other services, other types of engagements that we do, one of them being mobile assessments. They kind of follow like the gray box approach, whereas, mobile applications are usually going to be connecting back to some backend services. So there are some similarities there, and some similar, tools and stuff that we use for that. But there are some, differences and specifics that come along with mobile applications. The two main ones that come to mind are iOS and Android. So there's some differences even between those two. iOS applications, it used to be just Objective-C, but now you've got Swift as well. And then with Android, again, used to be just Java, but now you've got Kotlin. And then for both of them, there's actually frameworks now that will allow you to write in one language and kind of deploy to both, as well as possibly to deploy to other areas as well. So using things like the Unity engine, writing code in C# and then having that compiled down and working on both of those platforms. And there's other frameworks like that as well, that kind of live a little bit above those languages there to allow you to write for both. So there's a little bit of differences that can come with those. Some of the challenges that we face with those are jailbreak detection and certificate pinning. So, the part that's different from a web application, you have this client side that's communicating usually over an API. And one of the initial things that we might have to get through is if we're going to be testing on devices or simulators, there may be checks with applications to try to prevent those from running in those situations. Not all applications do that, but some of them it makes sense to do something like that. More in the interest of protecting the user. Mainly I'm thinking of things like banking applications tend to do that mostly as a way to, prevent a user from running on a jailbroken device on the off chance something might be running on there that could compromise their accounts, as well as mobile device management or MDMs. The point of those are to kind of lock the device down so you can kind of adhere to a corporate policy. So by definition, those things are going to ensure that you're not jailbreaking and enforcing certain policies. So, with applications, sometimes these are challenges we run into. We can try to get around those types of things, and it's kind of a cat and mouse game. You're looking for certain things in the operating system, but if you're running on an operating system with elevated privileges against an application that was meant to run in a sandbox environment, given enough time, you can probably always win against that kind of stuff. Certificate pinning, what that does, that's going to pin the traffic to specifics in the certificate on the remote server that the APIs might be connecting to. So that's going to prevent things like proxying traffic, where you introduce your own certificate in the middle and try to man in the middle of that traffic. And this is useful for, you're using your application, you're out in a coffee shop, you don't want to be man in the middle. So it's a good security control to have. But as security testers, that prevents us from man in the middling the traffic. Now, it's not a control to prevent us, as an attacker from man in the middling, because again, that's something that with modifications to the application or dynamic instrumentation, eventually we can get past those. But those are some of the typical challenges we can run into when doing a mobile application assessment. One of the things that we'll do is see if we can't get a build that doesn't have those controls in place. That helps us to focus more on doing the assessment as opposed to bypassing those types of controls. But again, if sometimes these applications might not be developed directly by you, but you might outsource your development, it might be difficult to get a build like that without those in place. We can still work on getting around some of those types of things. Some of the stuff that we see, if we can back up just a little bit, sorry. Some of the other stuff that we see though with these, again, on the client side, that's specific, is kind of managing, secure information, passwords, logging in. A lot of times you're using like fingerprints to log in, and usually that comes along with storing the credentials for the user or tokens. So there's, again, some more specific stuff there with, using, say, iOS keychain or the Android key store to securely protect things. So there's some of the differences there with the mobile assessment that's different from like web applications, is that client side. Okay, and then API web service testing, we can do that as well. And again, with the mobile assessment, some of that kind of includes API testing here because they're going to be communicating with APIs. But when we're looking at strictly an API without any, say, web application or mobile application involved, that also comes with its own challenges and issues that we have to look at and address. So we're basically going to be looking at an API most likely like a developer would. So we just have the API, but we don't have any application to exercise it. At this point, we have to be able to make successful calls to the API before we can even test it. So we need to make sure we have proper documentation, understand the APIs. Are there any workflows? You know, can we just make a call to each one of these endpoints, or you know, is there kind of a flow where we have to say get authentication, get the token back, and then insert this token in the specific field header or something like that, and then pass to the rest of the calls. Do we need to get some kind of an identifier from one call to pass into another call before we can do that? So, documentation is very helpful here. A lot of times we ask for like Postman collections or SOAP UI collections, depending on the type of web service or API that we're looking at. But those are some of the challenges. But again, this will come down to being very similar to doing the gray boxes. And a lot of times when we have applications with APIs, those will get tested in there. It's just the difference is when we're looking at an API alone, we don't have the nice pretty GUI or an interface to just make a request and then watch the API and then make minor modifications. At this point, we have to craft up calls from scratch, and hopefully relying on good documentation or collections already available, it might make some of this testing a little bit easier. But that's some of the challenges we look at with the API testing. Another one we do and see a lot is desktop applications, and we see some common things with these. Similar to like a mobile application, but with desktop applications, sometimes we see that they'll have a direct database connection. So if a user takes apart that application or they're monitoring traffic, you can see that if you're connecting directly to a database, there's going to have to be a connection string there and a user connecting to the database. So if the application itself might limit you in terms of what goes in the SQL query, and even if you're doing parameterized queries and doing everything correctly, if I can grab that database connection string and connect directly to the database, I'm going to have access to insert, select, and modify anything that the user of the database would have. So, in that case, what we recommend is using APIs, as kind of a middleman in between the application and the database, because you can limit the actions a lot better in an API as opposed to, trying to protect that SQL connection string. We see people trying to do code obfuscation against desktop applications, to try to, and we'll talk about that a little bit on the next slide, but, storing database credentials in the application, the correct way to address that again is moving to something like an API as opposed to trying to obfuscate that or hide that in the application. So other things we see, again, developer options or admin options, sometimes, typing the right thing or clicking on the right spot in the application will pop up a menu that will give extra access, so, or debug menus, or hard-coded URLs that go to test or staging app, sites or APIs that are still accessible publicly. So those are some things that we see as well to try to watch out for when you're looking at desktop applications. And then code obfuscation. So this comes into play a little bit more with mobile and desktop applications where the application is going to be in the client hands. So some clients, we don't see them using any code obfuscation, some we do, but sometimes I also think there might be a misconception as to what the purpose of code obfuscation is for. When would you use that? So one of the major reasons you would want to use code obfuscation, the first thing is it is going to make things more difficult for an attacker who's tearing apart your application. Some options are more effective than others, and we won't get into recommendations for which ones, but in general, the code is going to be on the device. It's going to be able to be executed and ran at some point if the device or the computer operating system is able to interpret and run those commands. An attacker with enough time could pick that apart and figure it out. So what is the purpose of code obfuscation then? Well, one of the good reasons for code obfuscation would be around intellectual property protection, DRM licensing. And what I mean by that is, if you're licensing an application and it's $30 to buy the app, and you have to enter in a license code without any code obfuscation, in a language, say, such as C# or something written in .NET, that could be very easy to take it apart, find that, area and patch it out. The purpose of code obfuscation here would be to make that a little bit harder for the attacker to where it wouldn't be worth their time or effort and it would be easier just to hand over the $30 to pay for the application. So that's where code obfuscation comes into play. Somebody might spend enough time and be able to figure it out, but why bother if it's just going to cost me $30, or move on to the next target. This is too hard to figure out how this works. Let me move on to an easier target. So the purpose is to slow down attackers, but it shouldn't be used for protecting critical resources such as encryption keys or credentials. So again, this isn't a fix for you've got an encryption key hidden to protect sensitive data, or you've got a database connection or hard-coded credentials, with administrative level access. Putting code obfuscation on it is not going to be the correct way to address that. It really should be used more just to kind of protect intellectual property, or DRM and licensing type stuff, and it makes things a little bit harder. It's another security control that can be put in place. It makes it a little harder to understand the application. It shouldn't be used to defend anything that's attempting to be secured within the application source code.
Alrighty, moving forward with some tools and technologies, we wanted to bring up some considerations when you're taking a look at tools and technologies to assist your application security program. There are a lot of commercial scanners out there, both dynamic and static application security tools and testing tools that are out there. One of the big considerations is with intellectual property and your source code. Where does it actually store your code? Do you upload your zip file of code and it pushes it out to the cloud, and now your code's out there with whatever cloud provider they're using, or is this something that stays local? Another consideration that Rob and I definitely have dealt with, does your code actually need to build? Does it need all its third-party components in there? Having worked at a Fortune 1000 company that was global, it was a challenge with some of those libraries that maybe weren't provided, might be in different languages that I didn't know. There were a lot of different challenges, unique challenges to do our due diligence with those types of applications. So some of those, especially around static analysis, require your programs to build, your projects to build, and that was a challenge that we had faced in the past. Also, what if you bought a third-party product and all they provide you is some compiled code, whether that's a binary or a DLL or whatever it might be? Is that a requirement? Do you need to be able to analyze those? That's a very unique situation. However, it's one that we run into a lot of times with clients, and it'll be after the fact, they'll be like, oh shoot, there's a vulnerability, but it's in the third-party product that we don't own. We just purchased and we have a license to it, but we don't actually have a way to patch it. So another piece to that is your third-party component licensing. Especially if you're developing software where it's going to be sold, a lot of those open source libraries or free libraries that are out there have different licenses. So there are products out there, I can think of at least two, that will scan your code, identify all of the different types of products or libraries that are used in there, and will analyze the types of licenses that they have, and will kind of make sure that you are using it in a legal way. Some of the free and open source software is labeled not for commercial use, so that's an interesting piece from a legal aspect that you might want to take a look at. Also, target limitations. Some of the licensing, when you're buying these tools, they might limit the number of hosts you can scan, the number of lines of code, the number of active projects. If you're trying to do something, you have one project that you scan once a month, sometimes there are limitations on that. So be careful when you're procuring those tools, different types of licensing. And then lastly, the integration with other tools. A lot of these static source code analysis tools will have IDE plugins that will allow your developers to submit the code for analysis and things like that. Also, some of the defects or bugs might be fed into another vulnerability tracking system or something of that nature. But there's a lot of different integrations between these tools, and you'd want to explore those as well before you procure them. Away from kind of the development side, more from your security tester side, we typically use Burp Suite, and that is a local proxy. And what that allows us to do is inspect traffic between the application and the server and see what's being passed back and forth, and inspect that traffic, modify it bidirectionally. So that would be kind of something to look at for more of your security testers. And then also, last one to mention, PTF, the Pen Testers Framework, something TrustedSec is involved with. And basically, it's a collection of tools that are out there to assist in security testing. And then finally, we're going to talk about a couple of the client challenges we've seen, common things that we've run into that are kind of learning experiences. With APIs, we've noticed some of the authentication and authorization checks may not uniformly be enforced. So we might have a web application that has a front end that enforces those authorization checks. You're only allowed to see your data, not other folks' data. However, if you use Postman or SoapUI or whatever it might be to hit the API directly, some of those checks might not be in place. That's some of the kind of themes we've seen with a few APIs we've tested. Others are file type restrictions. Let's say we have an ASP.NET application and all the ASP.NET type files are protected, whether it's VB, CS, ASPX, whatnot. And then a certain file type might not be protected. For example, PDFs. Maybe it's an insurance site and we generate our ID cards for our automobile insurance. Maybe the PDF file type is not protected. That's something we've seen. Also, roll your own anything. Don't reinvent the wheel. Encoding does not equal encryption. So when you have to protect sensitive information, things like base64, ROT13 are definitely not encryption by all means. So it's important when you're trying to protect something to do it the right way. Another piece we've seen is business logic flaws, kind of workflows and the flow of the code and doing it in the right order. We've taken advantage of some of those. So outside of just functionality testing, doing some security testing as well. Something that continues to plague applications and still one of the top 3 ways we break in is authentication mechanisms. We still see a lot of user enumeration through password reset and other registration options where it says this username's already been taken, and we can use statistically likely usernames to run a list of common usernames to go through that. And as Rob touched on as well, verbose error handling or having any sort of lingering debug test info or accounts out there. So when we promote things to production, we want to ensure all of that data is scrubbed and that we don't have any of that kind of stuff that an attacker might take advantage of hanging around in the background. So that's it for today. We've taken a look at software security kind of as a whole, where we've been and where we are now, overlooked an overview of OAuth, a couple things in the cloud, trends, application planning and testing terminology, and a few of the tools and techniques. So I'll turn it back over to Nathan.
Yeah, thank you, Scott. Thank you, Rob. Thank you, Geoff. We do have time here for a few minutes of questions, and we have a couple here, but while we're waiting for some of the other questions to come in, I did want to plug real quickly something that we have going on tomorrow. The team will be on our Slack channel doing an AMA, an Ask Me Anything. So if you want to have a little bit more in depth of a conversation about anything that you heard here, if you have any other questions, that would be a great place to ask that. So it starts at 1. I think if you ask any questions about shopping carts, you might get some entertaining stories or answers there. So highly encourage anyone to join our Slack channel. We have, they have there's a jobs channel on there along with other ones, all of our other teams. So anyway, I just wanted to plug that again before we get started. So please go ahead and enter any questions, any more questions you have into the Q&A. We're going to take a couple minutes here to ask them. And one question that I actually have is, how often are you guys coming across vulnerabilities kind of in the wild? Talking about the web today, how often is that? Is it very common? Is it not common?
I'll go ahead and take that. This is Scott. I would say it's quite common. If you take a look at the OWASP testing guide, there are many things that affect the overall security posture of a web application and its environment. So that could be from the web server itself, SSL TLS configurations, to the coding. Just in basic usage of public websites, not only our team, but other teams commonly find issues without even testing. For example, one that was actually posted yesterday, someone was signing up for some sort of financial related bank account or something like that, resetting a password, and the limitation was 8 characters for the password. So we don't actively go out poking and prodding at sites. We don't have permission to do that. However, during normal usage of sites, we definitely do notice opportunities for improvement as we use those.
And this is Rob here. You know, as we said, you know, as web changes, while we might not see certain types of vulnerabilities as much anymore, and they may fall off, we see new ones popping up all the time. So as technologies change and people are still learning to use new things, usually security is not the focus on that for a developer. They're just focused on getting it working and getting it right. So, you know, once you get to that point, sometimes they can forget to come back and try to do something the right way or the secure way once they've got it working. And that often can end up in that deployed code. But, you know, we still see, you know, a very common thing is, you know, you have an order ID, and by just changing the order, you know, the number in the order ID, seeing someone else's data. So, you know, even that's been around for a while. We still see stuff like that a lot.
Cool. Question here about metrics. What kind of metrics do you see for application security to show the progress or improvement? How do you know, whether you're doing a good job or not?
I'll go ahead and take that one. This is Scott. Being kind of in charge of or tasked with that exact question for a Fortune 1000 company that's global, that started off with domains all over the world, kind of coming back to one centralized IT location, is quite challenging. What I can say is when you go down to tracking vulnerabilities, whether it's vulnerabilities as a whole with the vulnerability management program or specific to application security, I would suggest that you not track the number of vulnerabilities. And the reason of that being is quite simple. Let's say you are doing authenticated scanning of all your desktop computers of your environment. Let's say you have 1,000 of them, and you are behind on Adobe Flash Player if you have that installed for some reason still, or Adobe Reader, and each of those have 20 vulnerabilities apiece. So you have 1,000 computers, and you have, between those two programs, 40 vulnerabilities on each one, and you go and patch those. Maybe you had 100, say you had 500,000 vulnerabilities for the whole organization, and we patched 2 programs. Oh, look, we just dropped it by 100,000 or whatever that math comes out to be. That looks like a lot of impact, but not really, because that's a program on perhaps a local computer. So with applications directly, what I chose to do is I mapped the type of vulnerability found, the category, for example, injection or SQL injection or cross-site scripting, and I mapped it to the OWASP top 10. And then I also mapped it to the development team. And I just, if there were 50 instances of cross-site scripting, I would just log cross-site scripting. And another reason why you would not want to log the number of them is, let's take Amazon, for example. Let's say they have a generic page, this view product. What if the cross-site scripting was in that view product page? If you pointed an automated scanner at it, it would show up on every product that Amazon has. So you'd probably have millions, if not billions, of instances of the cross-site scripting, whereas in the code, it's actually only in one location. It's in the view product page. So you have one instance of it. However, the end user sees more of it. So I would suggest taking the type of vulnerability, and if you can, pair it up with the development team. And what that allowed me to do is say, oh, look, I continually get these types of vulnerabilities out of this particular development team for this project. and that would allow me to allocate some budget for training to that particular team. So I could show improvement that way. So that's kind of my opinion on it, and having been tasked with that for a global company, and some of the pitfalls of counting vulnerabilities.
Great. I have a question here specific to application pen tests. What's included in them, and why is that a challenging term?
An application pen test is a challenging term because pen testing and application testing usually really have different goals. Pen testing is trying to evaluate kind of an overall security posture. What can somebody who's trying to get in do? Application testing usually is trying to really look at identifying all of, or as many as possible, potential flaws in the application that might be exploited. So the objective is quite different in that regard. So we really don't use the term application pen testing too much at TrustedSec. We do, gray box application assessments, and then we do pen tests. If that helps answer the question.
Yeah, I think that helps. Question here: would you increase the criticality of vulnerabilities over time as they become baked into more of the hacker tool sets?
In my mind, criticality really doesn't change too much. Typically, the degree to which something is exploitable remains what it is. Certainly, you get to a place where an attack may be automated that takes it from a more advanced a more advanced multi-step process that someone with a fair amount of understanding is able to execute versus point this tool at it, point this Metasploit module at it type attacks. However, usually when we assign severity ratings, we're really looking at it as is this a multi-step thing? Do you need to first exploit this, then leverage this to get success and use that vulnerability effectively for an attack, or is it one and done, regardless of whether the tools exist to set something like that up? So for us, the complexity doesn't really change a lot just because someone builds a tool, but complexity feeds into our severity ratings. As far as the rest of what goes into a severity rating, it really is going to be impact in terms of what data does it affect, what can someone do with this.
And this is Rob here, just to add on that too. I think the biggest change you probably see in that is more so going from something that's a vulnerability with potential for remote code execution with no known exploit at the moment to now it has a known exploit. So that may definitely change the severity or the priority of addressing that. Definitely something with that kind of potential should be addressed before it gets to that point. But once it gets to that point, that could definitely change the priorities. And then the second thing I think is maybe just determining what system that it was found on. So is that something, say, in a PCI zone type system, or is this something on a system that's kind of isolated, disconnected from the rest of the network and doesn't really have anything in terms of sensitive data? So the criticality of the vulnerability itself might not change, but maybe the overall criticality rating changes just based on the environment and kind of prioritizing, your sensitive systems first.
Cool, thank you both. Last question here, I think we're gonna end on this. How often have you had an opportunity to operationalize a cross-site scripting vulnerability as part of a larger engagement, such as a means to gain a foothold?
I'll go ahead and take that one. This one's Scott. We do encounter cross-site scripting all the time. If it's an application assessment, as Geoff had alluded to, it's kind of the goal to find as many vulnerabilities as possible. This question goes more towards, I would say, an external pen test or a red team engagement where we would be doing specific targeting, trying to get that foothold and move in farther. We have done this several times for various things. Usually it would involve loading other things like HTML applications like HTAs. Years ago, we might utilize something like a JavaScript, or excuse me, Java applet, not JavaScript, Java applet. But the biggest piece that I've seen here where we've used it is a customer service chat functionality, where you go into the chat and you type in your name and your question. And the name field has been vulnerable to cross-site scripting. And first we'll go in and we'll do something that is not visible on the screen. So whether it's some sort of image or CSS or some sort of a thing to hide what we're doing, and we would host an external web server, see if it actually calls out and tries to reach our server. If it does, that shows that it's rendering on their side. And sometimes you'll get lucky and it'll render multiple times, meaning there are multiple customer service folks on the other side that have viewed it or that it's popped up with. And through that, we can re-enter the chat, pose it with a real question and use that to our advantage. And, if you get a warning pops up or something to run on HTA, folks often don't know what's going on, so we'll just keep re-entering the chat. Eventually, somebody's going to click yes, and that has gotten us a show. So that's kind of the most common I've seen.
This is Rob here, just to add on to that too. A really good example of this too is like a stored cross-site scripting, where maybe something is loaded on the page that each person visits. So maybe you're putting something in there, on your profile page, just waiting for an administrator to get there. And while we might do something as a proof of concept, but it might not actually get exploited, an attacker with time might put something on there and wait for that to happen, where that could, say steal a session cookie and send it back to them, if the circumstances are right. So, even if we don't say necessarily exploit something like that, stored cross-site scripting with the right scenario like that, it might still be possible for someone with more time to sit and wait, or, say reach out for help and engage someone to say, go check out their profile. So that way they know it's going to get triggered. Sometimes they can require some coordination, which we may not always be able to do in terms of an engagement, but it doesn't necessarily mean you shouldn't take them seriously.
All right, I think with that, we will end today's webinar. Thank you, Scott. Thank you, Geoff. Thank you, Rob, for taking the time. For everyone who watched, hopefully you found a lot of value in this, and thank you for your time as well. So again, from everyone here at TrustedSec, thanks for the time.